Welcome to Rani Chemistry classes. In this video, I am going to discuss about the weekend test 2 conducted by Board of Intermediate Education for first year in the second chapter, that is structure of atom. First one is the number of radial and angular nodes of a 4f orbital are respectively. Here they are asking radial and angular nodes. Option 1 is 0, 3, option 2 1, 2, option 3 2, 1, option 4 2, 0. Here the radial angular nodes are nodal planes. Nodal planes are angular nodes are nothing but where the probability of finding electron is 0, this is equal to L, that is azimuthal quantum number. That is azimuthal quantum number. For s orbital, L is equal to 0. For p orbital, L is equal to 1. For d orbital, L is equal to 2. For f orbital, L is equal to 3. Here they are asking for the 4f orbital. For 4f orbital, F, L is equal to 3. Here number of angular nodes are equal to 3. Next they are asking, that is radial nodes. So for radial nodes are nothing but spherical areas inside an atom where the chance of finding an electron is 0. For the calculation of radial nodes equal to n minus L minus 1, where n is the principal quantum number, L is the azimuthal quantum number. For 4f orbital, n is equal to 4 and L is equal to 3 minus 1. So this is equal to 0. Here radial nodes are 0 and angular nodes are 3. So option 1 is the correct one. Okay, next second one. What is the correct orbital designated of an electron with quantum number n is equal to 4? Quantum number n is equal to 4, L is equal to 3, m is equal to minus 2, s equal to plus 1 by 2. N means principal quantum number, that is 4. L is equal to 3 means the orbital is f orbital. L is equal to 3 means already we have discussed. L is equal to 3 means f orbital. So the given options, first one is 3s, second one is 4f, third one is 5p, fourth one is 4d. So based on n and L value, we know which is the correct designated orbital. Okay, so option 2 is the correct one. Next, third one, the pair of ions are having same electronic configuration. First one chromium plus 3, Fe plus 3, second one Fe plus 3, Mn plus 2, third one Fe plus 3, Co plus 3, fourth one Sc plus 3, Cr plus 3. Here chromium, first option, third one, chromium plus 3, Fe plus 3. Chromium atomic number is 24, that is 3d5 4s1. 3d5 4s1 plus 3 means 3d3. Iron 26 means 3d6 4s2 plus 3 means 3d5 4s0. Next, option 2, Fe plus 3, Mn plus 2. Fe plus 3, iron atomic number is 26, 3d6 4s2 plus 3 means 3d5 4s0. Manganese atomic number is 25, 3d5 4s2 plus 2 means 3d5 4s0. So these are having the same electronic configuration. Next, third option, Fe plus 3, cobalt plus 3. So this is the right answer. Fe plus 3 means 3d5 4s0, cobalt 27, 3d7 4s2 plus 3 means 3d6 4s0. Next, fourth option, scandium plus 3, Cr plus 3. Scandium atomic number is 21, 3d1 4s2. So 3d0 4s0. Chromium is 24, 3d5 4s1 plus 3 means 3d3 4s0. Here same electronic configuration is there for Fe plus 3 and Mn plus 2. So option 2 is the correct one. So same question is asking for the same options. Which of the following pairs has same magnetic moment? Mu. Mu is equal to root of n into n plus 2. Here 5 unpaired electrons are there and maximum magnetic moment also exhibited by these two ions, that is Fe plus 3 and Mn plus 2. Okay, so this is the right answer. Next, fourth one, identify the pair which is not isotopes. Isotopes means having same atomic number but different mass number. The first option 6 6, atomic number is same but mass number is different, so they are isotopes. Second option, atomic number is same, so these are also isotopes. Third option, 6 and 7, atomic numbers are different but mass numbers are same, so these are isobars. Next, here 5 5 7 8, these are also same atomic number, these are also isotopes. So option A, option B, option D are isotopes. Option C is the only isobar, that is which is not isotope. So option C is the correct one, that is third option. Okay, next, fifth one, maximum number of electrons in a subshell of an atom is determined by the formula. Maximum number of electrons in an orbit is equal to 2n square. An orbit or shell equal to 2n square. Maximum number of electrons in a subshell equal to 2 into 2l plus 1, because 2 means each orbital contains 2 electrons. So number of orbitals are 2l plus 1. Total electrons mean 2 into, because each orbital contains 2 electrons. So this is equal to 4l plus 2. So option 4 is the correct one. Okay, this is the fifth one. Next, sixth one, if n is equal to 6, the correct sequence of the filling electrons will be. So we know the Euler's diagram, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. Electron first enters into 1s, next 2s, next 2p, 3s, next 3p, 4s, next 3d, 4p, 5s, next 4d, 5p, 6s. Next this, here n is equal to 6, that means electron first enters into 6s, next later on 4f, later on 5d, next 6p, 6p. So for this is the order of entry of electrons. 6s means ns orbital. For 4f orbital, n is 6 minus 4, that means n minus 2. For getting 4, n minus 2 f orbital. Next for 5d, n minus 1 d, because 6 for getting 5, n minus 1. Next np. So this is the order of filling of electrons when n is equal to 6. So for this option is given ns, n minus 2f, n minus 1 d, np. So first one is the correct one. Next, seventh one, match the following. Planck's constant is indicated by the symbol h. It is 6.626 into 10 power minus 34 kg. So here, so for Planck's constant, third one is the correct one. Okay. Next, E by M ratio of electron is 1.75 into 10 power 11 coulombs. Here 9 is not there. 1.75 into 10 power 11 coulombs. So E by M ratio is fourth one. charge of electron is 1.602 into 10 power minus 19 coulombs. This is the wrong. So option 1, first one. Okay. Next, Rydberg constant. Rydberg constant means 109677 centimeter inverse. For conversion into meters, 109677 into 10 power minus 2 meter inverse. So here this value is not there, 1.0. So for getting this point here, 10 power minus 2, 3, 4, 5, 6, 7. So 1.09677 into 10 power minus 7 meter inverse. So this value is present here too. So these answers are present in that is first one, third, fourth one, one and second. Third one is the correct one. Okay. Next, which one of the following is phosphorescent material? Which one of the following is phosphorescent material? This phosphorescent material absorbs light energy, and re-emits this energy as a glow in the dark. A glow in the dark. In the given options, PBS, cadmium sulfide, zinc sulfide, ZnSO4, ZNS exhibit the phosphorescent. The zinc sulfide absorbs light energy and it will be activated with copper and edge silver. Okay. So ZNS is the phosphorescent material. Next, the following of the radiation of wavelength 300 nanometers. Radiation of wavelength 300 nanometers. Here, the following of the frequency of radiation. Frequency is indicated by nu. Nu is equal to C by lambda, where C is velocity of light, that is 3 into 10 power 8 meters per second. Lambda is here given nanometer. So 300 into nanometer means 10 power minus 9 meters. So this is written as 3 into 10 power 8 by removing these two digits, 3 into 10 power minus 7. So 3 will get cancelled. 10 power minus 7, after going to numerator, it becomes 1 into 10 power 15. Units are Hz. So this is the value. First option 1 into 10 power 7 Hz, 3 into 10 power 7 Hz, 3 into 10 power 15 Hz, 1 into 10 power 15 Hz. So fourth one is the correct one. Okay. This is the ninth one. Next, 10th one. The number of neutrons, protons and electrons are. First one is neutrons, next protons, next electrons. Generally, the number of protons indicate the atomic number. So 16 is present in the first one is 18, 16, 16, 82. So first one is not suitable and fourth one is also not suitable, because here number of protons is 16, here number of protons is 18 and 18. So first option and fourth option will be eliminated. In the second and third option, number of protons are 18. Next to number of electrons are 18. Here 16 minus 2 means it gains 2 electrons. 16 plus 2, 18 electrons. Number of neutrons means number of neutrons equal to A minus Z. Here 32 minus 16. So number of neutrons are 16. So this is the suitable answer, because number of neutrons is 16, number of protons is 16, number of electrons is 18, because here 16 electrons are there. Minus 2 means it gains 2 electrons. So 16 plus 2, 18 electrons. So option 2 is the correct one. Option 3 is wrong answer, because here neutrons are 34 minus 16, 18 neutrons. So it is the wrong answer. So for 10th one, second one is the correct one. Next, 11th one. The wavelength of a ball bearing mass of 2 grams moving with a velocity of 100 meters per second in the matter is. Here wavelength is given. We know the de Broglie's wavelength lambda is equal to h by mv. where h is the Planck's constant. Take the round figure, that is 6 into 10 power minus 34 joule second. Round figure, we are taking mass of the ball is given 2 grams. So we are taking SI units. So 2 grams are equal to 2 into 10 power minus 3 kg. So 2 into 10 power minus 3 into velocity is 100. Okay. So here 2 1 jar, 2 3 jar, 2. So this is equal to 3 into 10 power minus 34 by, here 10 power minus 3 into 100. We are getting 10 power minus 1. This 10 power minus 1 from moving from denominator to numerator, 10 power 1. So this is equal to 3 into 10 power minus 33. 10 power 33 meters. So this is the answer. This option is present in 3. We are taking the that is Planck's constant round figure. So relevant answer we must select. That is 3.3 is given in 2 options. 3.3 into 10 power minus 34. 3.3 into 10 power minus 33. So option 4 is the correct one. Option 4 is the correct one. Okay, next 12th one. Orbital angular momentum associated with 2p electrons is orbital angular momentum. Orbital 12th one. Orbital angular momentum. Orbital means L value. This is the azimuthal quantum number, is also known as orbital quantum number. Orbital angular momentum is given by root of L into L plus 1 h by 2 pi. Here they are given 2p electrons, 2p with 2p electrons. For 2p L is equal to 1. Per p orbital L is equal to 1. Substitute 1 instead of L, root of 1 into 1 plus 1 h by 2 pi. So this is equal to 1 plus 1, 2, 2 into 1, 2, root 2 into h by 2 pi. So this option is not there. So we must modify this as root 2 into h by, this 2 is written as root 2 into root 2 into pi. So 1 root 2 will get cancelled. So this is equal to h by root 2 pi. H by root 2 pi is present in, that is the first option. Okay. Next, maximum number of electrons in a subcell with L is equal to 3 and N is equal to 4. 13th one, maximum number of electrons in a subcell equal to, formula is, that is 2 into 2L plus 1 or 4L plus 2. Okay, here 2, L is given in the problem 3. So 2 into 3 plus 1. So this is equal to 2 into 3 2s are 6, 6 plus 1, 7. So 7 2s are 14 electrons. So option 14 electrons is present. Option 1 14, option 2 16, option 3 10, option 4 12. So option 1 is the correct one. Next, the total number of orbitals associated with the principal quantum number S is. Principal quantum number S is. Here, actually generally we know the principal quantum number is indicated by the 14. N is equal to 1, 2, 3, 4, 5, 6 like that. Here they are represented as K, L, M, N, O like that. Here they are written like that. Here they are asking that total number of orbitals. Total number of orbitals are they are asking. Here total number of orbitals is, square of this is given is 20 is not there. So 25, 5 square, 5 square. 5 square means 25. So we have select this one as the principal quantum number associated with the S, like that KLMN. So for this S, n is equal to 5. N is equal to 5. N is equal to 5. So 5 square means 25. So for 14th one, option 2 is the correct one. Next, the following set is the quantum number is not allowed. When n is equal to 4, L values are ranging from n minus 1, that is 2. It is correct. Where L is equal to 2, M is 0 is possible. So first one is the correct one. Next, second one, n is equal to 3, L is equal to 2 also possible, because n minus 1 means 2. M is equal to 0. S may be plus 1 by 2 correct or minus 1 by 2 be correct. Next, third one, n is equal to 3 means L must be n minus 1. That means 3 minus 1. L values are ranging from 2, 1, 0. So this is not possible. For n is equal to 3 row, L is equal to 3 is not possible. So here L is equal to 2. M is equal to 2. So 3 is not possible. So this quantum number is not possible. Fourth one, n is equal to 3. L is equal to, it may be 0, 1 or 2. M is equal to 0. S equal to plus or minus 1 by 2. So option 3 is the correct one. Next, 16th one, the number of neutrons in the isotopes of 1H1, 1H2, 1H3, 1H3. H3. Here this is proton, this is deuterium, this is tritium. This is known as proton, generally H. This is deuterium, that is tritium. Okay, here they are asking the number of neutrons. Here number of neutrons formula equal to N is equal to A minus Z. In the first case, for 1H1, number of neutrons equal to 1 minus 1 equal to 0. For 1H2, number of neutrons equal to 2 minus 1 is equal to 1. For 1H3, tritium, 3 minus 1, this is equal to 2. So these are the neutrons. Total neutrons equal to 0 plus 1 plus 2. So total equal to 3 neutrons. A plus B plus C. So option first one 0, second one 1, third one 2, fourth one 3. So fourth one 3 is the correct one. Okay. Third one is the correct. Next, 17th one. A certain orbital has no angular nodes. No angular nodes. That means L is equal to 0. No angular nodes means L is equal to 0. Next, and two nodes. The orbital is 2 nodes means total nodes formula equal to total nodes n minus 1. Here number of nodes are 2 means n may be 3, because 3 minus 1 2. So here n is equal to 3. N is equal to 3. L is equal to 0 means s orbital. So for 3s orbital, no angular nodes and 2 nodes are present. So option 2 is the correct one. Option 2 is the correct one. Next, 18th. Statement 1. Splitting of spectral lines in presence of electric field is called JEE Mains effect. Statement 2. Splitting of spectral lines in presence of magnetic field is called Stark effect. Here both statements 1 and 2 are true. Both statements 1 and 2 are false. One is true, second one is false. One is false, second one is statement 1 is false and statement 2 is the incorrect option. Here, splitting of spectral lines in electric field is generally called Stark effect. Splitting of spectral lines in magnetic field is called JEE Mains effect. Both are wrong answers. So, both statement 1 and 2 are false answers. That is 18th one. So, second one is the correct one. Next, 19th one. According to Bohr's theory, The angular momentum of an electron in fifth orbit is given by, angular momentum of an electron is given by mvr equal to nh by 2 pi. Here n is given as fifth orbit, so 5h by 2 pi. Here this option is not present in the given options. First one is 25h by pi, second one is 1h by pi, third one is h by pi, fourth one is 2.5 h by pi. So here to get the value 2 multiplied this, we will get 2.5 h by pi, 2.5 h by 5. So fourth option is the correct one. Next, 20th one, the scientist who developed quantum mechanics is, first option Max Planck, second one de Broglie, third one is Werner Heisenberg, fourth one is George Uhlenbeck. So Planck, de Broglie and Heisenberg all made contributions, but Werner Heisenberg along Schrödinger directly developed the quantum mechanics and derived the complete mathematical system. So third one is the correct one, that is Werner Heisenberg proposed a Heisenberg uncertainty principle. So this is like and subscribe this channel. Thank you.